how do you teach a machine common sense? I mean, not just giving it facts, but teaching it the rules that connect all those facts together. Well, today, we're going to build a tiny AI brain right from scratch, just to see how it can learn to reason using this really powerful language called first-order logic. You know, at the very heart of AI reasoning, there's this surprisingly simple challenge. It's the one thing that really separates our human intuition from the way a machine processes information. For us, that connection is just automatic. Of course a king is a person, right? We don't even have to think about it. But to a machine, king and person are just a couple of meaningless labels. It's missing that underlying rulebook that we all have, the logic that connects all these isolated facts about our world. So, to solve this little problem, we need to give the AI a kind of grammar for reasoning. But as you're about to see, there is a huge difference between a language that can just state a simple fact and one that can state a universal truth. And this right here is the crucial leap. On the one hand, with propositional logic, you can state a simple fact. Socrates is human. That's useful, sure, but it's pretty limited. On the other hand, with first-order logic, you can state a universal rule. All humans are mortal. That one sentence, it contains a massive amount of knowledge about the world. It's the difference between just knowing a single data point and actually understanding a principle. So how do we actually start writing in this powerful language? Well, we start by sketching out our world, kind of like a video game designer would. We define its core objects and the relationships between them, and we do it using two key building blocks. Think of it this way. Predicates are like your verbs or adjectives. They describe things or what they're doing. And variables, like this x here, they're just the nouns, the placeholders. When you combine them, you can form statements that are either true or false. So for instance, if we replace the variable x with Socrates, we get human Socrates. And boom, we have a specific fact that we can add to our knowledge base. Okay, now we're getting to the real engine of first-order logic. By just adding two special symbols, they're called quantifiers, we can take our simple little statements and turn them into these powerful universal rules that can govern our entire knowledge base. These two symbols are the absolute powerhouse here. That upside-down A means for all, and it lets us make those huge, sweeping statements. That backwards E means there exists, and it lets us say, hey, there's at least one thing out there with this property. Together, they would allow an AI to generalize from just one fact to an entire category of things. Just look at how this all comes together. First, in step 1, we anchor our world with a simple fact, human Socrates. Then, in step 2, we give it a universal law. For any x, if that x is human, then that x is mortal. And just like that, with only 2 lines, we've encoded a really fundamental piece of wisdom. Okay, so we've built our tiny knowledge base. What's the point? Well, the payoff is what happens when we ask it a question and force it to actually reason. This whole process is called inference. Inference is basically the spark of intelligence here. It's the system's ability to connect the dots all on its own, to figure out conclusions that it was never explicitly told. It's how knowledge creates new knowledge. Pretty cool, right? All right, this is it. Our entire AI brain consists of just these 2 lines, one fact and one rule. Now, let's test it. Now, remember, we haven't told the system that Socrates is mortal, not directly. We only told it he's human and that all humans are mortal. So now the system has to connect those 2 pieces of information all by itself. And there it is. Yes! The system correctly infers the answer. It applies that universal rule to the specific fact we gave it. It sees that Socrates fits into the category of human, so the rule about mortality must apply to him too. It has literally reasoned its way to a new correct conclusion. Now, this might seem like a simple little party trick, but don't be fooled. This exact process, encoding facts and rules, and then using inference to connect them, is happening at a massive scale inside so many of the complex AI systems that we use every single day. And that is the real power of inference. It's what elevates an AI from being just a simple database to being a reasoning engine. It's how it understands context, how it solves new problems, and even how it predicts outcomes. It's the bridge that takes a machine from just knowing facts to actually understanding them. So while we're building these absolutely incredible systems that can master flawless logical deduction, we're also faced with this really profound challenge. How do we use this same kind of logic to teach an AI about all the messy human concepts, like hope or justice, the things that can't be defined by a simple if-then rule? Well, that's the real frontier of AI reasoning. Thanks for watching.